flash drum. For this flash drum, let us find the process variables, manipulated variables, and the possible combination of these two that we will find. To find that, first we have to find the degrees of freedom. The liquid stream containing several components is partially vaporized in a flash at a particular pressure and temperature. This results in two phases. One is vapor phase, another one is liquid phase. So liquid phase is the bottom product and the vapor phase is the top product of the flash drum. Here, the feed is entering into the flash drum at a high pressure, say PF. The inlet temperature is Ti. The feed consists of N components. Zi I varies from 1 to N components in that feed. Its flow rate is FF. The temperature and pressure maintained inside the flash drum is P and T. The flow rate of top product, vapor, is Fe. It consists of Yi components. I varies from 1 to N. The bottom product is the liquid product. Its flow rate is FL. It consists of Xi. I varies from 1 to N components. The steam is used to heat the flash drum to maintain at a particular pressure and temperature. For that, the steam flow rate is Ws. The steam temperature is Ts. The level of the liquid inside the flash drum is H. Now, let us find the degrees of freedom. For that, let us write the equations. The total mass balance equation is A dH by dt. That is rate of change of volume multiplied by rho, rate of change of mass, equal to mass inflow rate, that is feed flow rate, minus mass outflow rates, vapor pressure and the liquid pressure. This is one equation. If you write the equation for component balance, A rho dHxi by dt, that is liquid phase, component balance equal to F of Zi minus Fey plus Fl Xi, where Y is the bottom product and X is the, Y is the top product and X is bottom product. Components in bottom product. This is components in top product. As I varies from 1 to N, this has N minus 1 equations. To write the heat balance equation, the rate of change of heat energy inside the flash drum equal to amount of heat entering the flash drum and amount of heat leaving the flash drum plus heat supplied. This is heat supplied. This is another equation. So equation number 1, N minus 1 equation and 1 equation. So far, N plus 1 equations. Vapor liquid equilibrium relationship is Yi equal to Ki Xi, where I varies from 1 to N, N equations. Consistency constraints, for consistency constraint, this is one equation, this is another equation. Therefore, N plus 1 plus N, 2N plus 1, here 2 equations, 2N plus 3 equations. Total number of equations equal to 2N plus 3. Number of variables is that I varies from 1 to N, Xi varies from 1 to N, Yi varies from 1 to N, and Ki varies from 1 to N. Ki varies from 1 to N. Therefore, total number of variables 4N plus we consider all other variables A, rho, F of FE, FL, you will get 14. So total number of variables equal to 4n plus 14. Out of this 4n plus 14 variables and number of equations 2n plus 3. In addition to that, out of 4n plus 14, n plus 7 are constants A, AS, rho, U, CPF, CPV, CPL, KIs. As I varies from 1 to n, you will get n plus 7 constants that we have to subtract from this 4n plus 14. So minus n plus 7. Out of 4n plus 14, we have to subtract n plus 7. N plus 7 minus externally specified. We are not able to specify. That is defined by the ambient condition. That is feed of the temperature that we have to subtract. That is 1. And Zi varies from 1 to n minus 1. Again, you have to subtract one more n for externally specified. So the remaining 2n plus 7, if you subtract, that is equal to 2n plus 7 unspecified. Unspecified. Therefore, degrees of freedom equal to unspecified. That is 2n plus 7 minus number of equations 2n plus 3. That is equal to 4. Degrees of freedom equal to 4. That is f equal to 4. Therefore, we can control only 4 variables. Therefore, number of process variables equal to 4. So what are the process variables? 4 variables we have to control. Let us consider this flash drum. Here, to get enough quantity of output, the feed flow rate has to be maintained at certain level. Therefore, f of feed flow rate has to be controlled. To get required quantity, f of has to be controlled. To get quality product, because quantity as well as quality both are important. Therefore, to get quality product, the temperature and the pressure has to be maintained. That's why another 2 variables we got. Then the level, the bottom product has a level of H. This H should not go beyond a certain level. If it go above that, the pressure will go unsafe value and it may lead to damage of the equipment. So to avoid that, the level has to be maintained. At the same time, this level should not fall 0. That is also dangerous. The temperature will go beyond a certain unsafe value. So that the level has to be controlled. Therefore, the 4 process variables as per requirement are feed flow rate, pressure, temperature, and the level. What are the manipulated variables? To control all this, we have to identify. One is we can use feed flow rate as one manipulated variable, steam flow rate as another manipulated variable, liquid flow rate, one manipulated variable, and vapor flow rate. These are the 4 manipulated variables that can be used to control these process variables. But how to select, how to relate which manipulated variable? This is 1, 2, 3, 4. Whether f of can be used to control f of or P or T or H, that we have to find by qualitative analysis. Why? Because FF will have impact on all the four. If FF increases, feed flow rate increases, so feed flow rate increases. So it can be used to control FF. If feed flow rate increases, pressure will increase. If feed flow rate increases, temperature will decrease. If feed flow rate increases, H will increase. Therefore, feed flow rate can be used to control all the four. Steam flow rate, if you consider, if steam flow rate increases, pressure will increase. That's why pressure inside the flash drum will increase because of increase in temperature. Therefore, FF will decrease. Pressure will increase. Temperature will increase. H will, as temperature increases, H will decrease. Because vaporization will be more, that's why H will decrease. So WS can be used to, steam flow rate can be used to control all the four. Then the third case is FL. If you use FL, if you manipulate FL, what and all will happen? H will vary. If you increase FL, H will decrease. As H decreases, temperature will increase because for less quantity of liquid, we are supplying the same steam. That's why T will increase. As T increases, P also will increase. More vaporization. That's why P will increase. The same time, FV also will increase. So FL can be used to control all the four variables. Similarly, FV cannot be used to control all the four. FV increases, pressure will decrease. Pressure will decrease. That's why temperature will increase. As FV increases, as temperature increases, more vaporization. That's why H will decrease. As pressure decreases, feed flow rate will increase. Feed flow rate will increase. Downstream pressure decreases. That's why feed flow rate will increase. Therefore, this also having impact on all the four process variables. That's why we have to select which manipulated variable has to be used to which process variable. There are four process variables, four manipulated variables. All the four are measurable. What are the possible combinations? 4 factorial possible combination. That is equal to 24 possible way we can combine the manipulated variable and the process variable. Out of these 24 possible combinations, we have to select only one.